I will introduce our group member. For the first one is Muhammad Haziq Daniel bin Rais Bambang Noto Kusumo, AF 190106. Okay, the second one is Aira Akila binti Abdul Wahid, AF 190056. The third one is Nur Ain Nashwa binti Aminuddin, AF 190124. Myself, Nur Rikharatul Aish binti Muhammad, AF 190117. Okay, and the last one is Nur Shamimi binti Mat Yusof, AF 190088.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Rikharatul Aish binti Muhammad, matrix number AF 19110. Okay, first thing first, I will give an introduction about our topic, which is slope remedial technique in slope stability. Okay, slope failure can be defined as a phenomenon that a slope collapses abruptly due to the earth under the influence of a rainfall of the earth under the influence of a rainfall or an earthquake. Okay, many know that slope failure or landslide had caused the destruction of people's homes and lives. Okay, this is because of many factors of slope failure. Okay, slope failure also happen around the globe at any time and in places that have hills or any land slope-like structure. Okay, the slope failure happens due to several factors, which is mostly our human doings. But to be fair, that the slope were also created by humans, the engineers. They had created the slope with their knowledge. Okay, to specify to create a slope, they must not ignore one of the main focuses, which are slope stability. The focus of measuring slope stability is for preventing slope failure. Okay, next. Okay, this is our objective for our project. Okay, the first one is to identify techniques of remedial slope failure for a specific cases. Okay, the second one and the last one is to identify the suitable techniques of remedial of slope failure based on the case given.
Next, I will continue the presentation for technique of slope stability. There are three techniques of slope stability, which is the first one is installing a retaining wall, second installing a drainage, and lastly applying shotcrete. The first one is retaining wall. Retaining wall are moderately rigid barrier that hold soil laterally, allowing it to be maintained at different level of both sides. A true retaining wall is the best type of wall for a hillside, which are beneficially where heavy load are predicted or whether the wall itself should be slender or otherwise be too brittle. Next, drainage. A temporary drainage also need to provide since the most retaining wall are impervious, which means water cannot pass through the wall. If there is no drainage, water will compromise the safety and structure of the retaining wall. Horizontal drains can be used to remove the water from behind a wall in application where subsurface flow rate are high. Lastly, shotcrete. Shotcrete is a popular solution for slope stabilization because of its adaptability, durability, early resistance, and ability to stick to the substrate. There are two types of shotcrete, which are dry mid shotcretes and wet mid shotcrete.
Hi, my name is Nur Shamimi binti Mat Yusof, and I will continue with the application of any standard. There are four applications, which are slope straightening work, design field slope, site supervision and coordination, and surface protection of slope. First application is slope straightening work. Work on slope stabilization. Soil nail is widely used for both restresses slopes and very steep cut slopes as a stabilizing tool. The popularity of slope nails stems from its technology appropriateness, as some successful slope stabilization technology, as well as its ease of construction and low maintenance requirements. As a result, motorways, basement excavation, and hillside development projects have employed soil nail slopes up to 25 meters high. Reinforced shotcrete surfaces are typically used for soil nail. Next is design field slope. Before depositing the field on a field slope, the vegetation, topsoil, and any other undesirable materials are removed. The foundation layers are additionally benched in order to anchor the field on an existing slope. To avoid the likelihood of high pore pressures developing and producing slope instability, a free draining layer according to the filter requirements is typically required between the field and natural ground, especially where there are existing intermittent streams and depressions. Next is site supervision and coordination. Supervision personnel should have sufficient knowledge and experience in geotechnical engineering to identify any irregularities in the subsurface condition. For example, the soil types, surface drainage, groundwater wicks, plants, and others that differ from those anticipated and adopted in the design. Close coordination and communication between the design engineers in the office and the supervising engineers is required so that the design may be modified to meet changing site circumstances as needed. This should be done properly during construction to avoid failure and needless corrective work over the slope's service life. Before, during, and after construction, enough pictures of the site should be obtained. This image should be accompanied by the information such as dates, weather condition, or abnormalities in subsurface condition discovered during excavation. And lastly, surface protection of slope. Close turfing or hydroseeding should be applied to all exposed slopes within a short period of time, not more than 14 days and 7 days during the dry and rainy seasons after the bulk excavation or filling of each berm. Before hydroseeding, all cut slopes should be graded to generate horizontal growth, which is not vertical growth, with appropriate motor grades. This is done to prevent gullies from appearing on the cut slopes due to flowing water before the vegetation has fully grown, and it also helps the plant thrive.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq Daniel bin Rais. My metric number is AF190106, and now I will explain about the long-term stability for the chosen technique. So, based on the technique suggested from this study, researcher will verify which of the retaining wall technique suitable for the long-term stability. So, the best retaining wall for the long-term stability, researcher had chosen the anchor retaining wall. To strengthen the point given, for a permanent structure, the general lifespan of retaining wall between 50 to 100 years, based on Muhammad Mukhlisin from Polytechnic Negeri Sembilan. Polytechnic Negeri Semarang. So, but the lifespan of the retaining wall mentioned depends on the condition of the soil. Results show that higher soil moisture content, soil density, soil thickness, and smaller soil particle, as well as steeper slope gradient, resulted in deeper soil settlement and greater potential for slope failure. Therefore, the related advantages of anchor retaining wall can support the long-term stability point. First, as mentioned from the previous chapter, the anchor retaining wall more stable. The use of cable and anchor DP embedded in soil will provide a reliable amount of stability to the anchor wall. Next, for the installation process of this retaining wall would be considered as easy and not taking more spaces due to the advantages of the slimmer than other retaining wall. Due to the structure of anchor of the retaining wall, it will consist the advantages of slope protection as it holds the purpose of retaining wall, which to make no movement of soil slope. So that's all from me.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Aira Akila binti Abdul Wahid, and I will present conclusion for our group. Based on the factors that cause slope failure at Bukit Antara Bangsa, the best techniques to remediate or prevent slope failures are anchor retaining wall techniques. which are moderately rigid barriers that hold soil laterally, allowing it to be maintained at different levels on both sides, are the best approaches to remediate or prevent slope collapse. As we all know, the distribution of rainfall, which has an impact on the physical properties of the soil, is the primary cause of the landslide or slope collapse. The weight of the soil that makes up the slope increases as a result of the slope absorbing large amounts of water. As a result, it is more vulnerable to soil mass movement. Apart from that, it decreases the cohesiveness of the particle grains that make up the slope, making it less resistant to movement and raising the risk of soil liquefaction. That's all from me. Thank you.